So the question today is, how do we know if a reaction is endothermic or exothermic? So what we want to do today is we want to look at the direction of heat flow. So the direction of heat flow will tell us if a reaction is endothermic or exothermic. So an example of an endothermic process is ice melting to water in air. So what's happening is ice is going to melt to water and air is the surrounding. So take for example the first one. The first diagram we have ice placed in a beaker of air, thus air is the surrounding. And at first the temperature of this surrounding air is 25 degrees Celsius. So what happens here is for ice to able to melt, ice need to take in heat energy. Okay, because particles in a solid are very closely packed together and there are strong forces of attraction. For these particles in ice to become particles in a liquid as it melts, these particles in ice need to take in heat energy. So where do the ice get the heat energy from? So ice will get the heat energy from air, and therefore the heat from the surrounding air will enter into the ice. And because ice has taken in heat from this surrounding air, this temperature of the surrounding air will then drop. So if you measure the temperature of the surrounding air, it may drop to, for example, 23 degrees Celsius. And if you feel the air around the ice, it will feel cool because the ice have taken in heat energy to melt into liquid. So how do we explain this? So we explain it in this way to say that heat energy is taken in or that it enters. For you to remember, enter means endothermic. So heat energy is taken in from the surrounding. Thus, the temperature of the surrounding decreases. So an endothermic reaction is a reaction where heat energy is taken in from the surroundings and the temperature of the surrounding will decrease. So for information, if you would like to know what happens to the heat energy, so what happens for only information, you do not need to write this down at all, is that heat energy taken in by the ice was used to overcome the very strong forces of attraction between the particles. And when this heat energy is taken in by these particles in ice, the potential energy increases. Therefore, the heat energy is converted into potential energy in the particles of a liquid. So therefore, if heat enters, meaning heat is taken in to overcome forces of attraction, for example in melting where solid becomes liquid, or in boiling where liquid becomes gas, or when more heat enters, meaning more heat is taken in to break the bonds, then heat is given off to form bonds in any reaction, for example thermal decomposition, or dissolving soluble salts like ammonium chloride in water, it is endothermic. So you do need to memorize that melting, boiling, thermal decomposition, as well as dissolving soluble salts in water are all endothermic reactions. So the question we want to ask ourselves again is, how do we know if a reaction is endothermic or exothermic? So we will look at the direction of heat flow. So this is an example of an exothermic process where we are burning, meaning combustion, of a candle in air. Air meaning the surrounding. So at first, before burning the candle, the air temperature is 25 degrees Celsius. As the candle starts to burn, what will happen to the surrounding air? If you take a temperature and you measure the surrounding air, the temperature of the air will go up. So which example, the temperature may go up to 30 degrees Celsius or even higher. And what does this mean? This means as the candle is burning, it is giving off heat energy. Therefore, the surrounding air gets hotter. So when the heat is being given off, when the heat is exiting from this candle that is burning, this is an exothermic reaction. So the explanation would be that as the candle wax burns in oxygen, this process is giving off heat, which we can also say as heat exits, because exit sounds like exothermic. So while this process gives off heat to the surrounding, thus the temperature of the surrounding will increase. So this portion is only for information. You do not need to write this in chemistry. This may help you in your understanding. So what happens is as the wax burns, the potential energy of the wax decreases, which is why we say the potential energy decreases in the substance. And this is released in the form of heat, which is the reason why heat is given off or heat exits and makes the temperature of the surrounding increase. So what are exothermic reactions? Therefore, as long as heat is given off, meaning it exits, to form stronger forces of attraction, for example, in freezing and condensation, or when more heat is given off, for example, exit, exothermic, to form bonds compared to the amount of heat taken in to break bonds, for example, in the reactions like combustion, burning, oxidation, neutralization, and rusting, as well as dissolving anhydrous salts or acid or alkali in water. These are all exothermic reactions. So you don't need to memorize that in these processes, freezing, condensation, combustion, burning, oxidation, neutralization, rusting, dissolving anhydrous salts, acid or alkaline water, these are all exothermic reactions where heat will be given off to the surroundings and the temperature of the surrounding will increase in such a situation like this.